Hello and welcome to my new video, which will be completely about the workflow of generating tendons in a slab in Revit and bring it straight forward to SOFiSTiK to perform the analysis and get results out of your defined tendons. So just a quick insight of what we have right now. So we are working currently on the level 2. There is an analytical model already available. So you see, this is my slab. I have also some conditions, support conditions available. And when we have a look into the 3D view, we see also the physical model of the slab. The slab as itself is quite thin one. It's only 150 mils thick. So let's change this to 200 millimeter. This will also give us a better view later on in the tendon geometry for the visualization. Okay, what do we need to do first? The first step in the generation of the tendon geometry within Revit is to create model lines. These Revit model lines actually representing the projection of the tendon and will be used later on also to assign further information of the high points. So generating a model line is a straightforward thing. So we are jumping back to our level number 2. I switch to the structure tab over here and I select model line. By default, the single line is selected from Revit, so we can leave this as it is. So let's start with the first model line. So I click on the command, I go over here on this left edge, select the midpoint and go over to the right side and also confirm this point. I close the command simply by hitting 2 times escape. So now we do have a model line available in our project. This model line needs to be now transferred to a SOFiSTiK related element. And how we can do that? In the next step, we are open the SOFiSTiK Analysis tab over here. And within the utilities, when you extend this ribbon, you find 2 further commands, create tendon projection and filter loads. So we are focusing at the moment just on the tendon projection. So just click on this command. Now the application asks you here on the bottom to pick the model curve you have created already, and we can do that simply selecting this model line over here. And we can finish the input. So now you see already the model line is highlighted in blue, and that means it already has some SOFiSTiK related information available. To check this information, first of all, have a look into the Revit properties of this line. And here we see already this is a SOF, which means SOFiSTiK in short, underscore tendon projection. However, we need definitely to put more information to this tendon line. And therefore, we need to have a look into this SOFiSTiK structural properties tab down here. In this tab, SOFiSTiK structural properties, we see straight away the properties of this tendon. Let's have a look into the different sections over here. We have the general, geometry, construction sequence, and prestressing. The general section gives you information about the prestressing system, which is required when setting a tendon geometry. So we have only one available here in our project. Furthermore, we can give this tendon a name, and I make it easy and simply write tendon. In regards to the geometry information, there are 2 layers available for the tendon. The first one is automatic, which is selected by default, and we have also user-defined available. For now, we stick with automatic to give you the first idea how it looks like. Basically, when I would change to user-defined, you see all the predefined options are faded away, which means it costs you more effort to build your tendon layout. However, this automatic is a straightforward input, but is also kind of limited in the flexibility. So, of course, there are some cases that you might need the user-defined layout. However, let's focus on this one right now. The first input is the distance from top. The distance from top means, as it says, it's the distance from the axis of the tendon, or the axis from the duct actually, from the edge of the slab, so from the surface, from the top surface. The same we have for the bottom surface. Then the straight length at top. You can also define a strength length to be considered for your tendons at this high point, so at the top position. And also there's the option to enter a transition length. Let's keep this here for now on 3000 millimeters. The next input are the stations, and this is quite important because you won't have always a simple geometry as I have here, so it might be important for you to add additional station points, which actually are the location of the high points of your geometry. So let's have a look what happened when I click here on Edit. We have here 3 station points available in this table. All of them are by default active. We also got the position along the tendon geometry. So we have a start end point at 0 and also at 10 meters. 10 meters was the total length of our slab and also represents the total length of the tendon. In the center we have already a high point available, and this is caused by the fact that I used a Revit grid element over here, which will be automatically recognized from the software, from the plugin, as a high point. So keep in mind, if you have a regular grid and also a kind of regular distribution of your tendons, this is definitely the tool you should go for. Consider those grid systems to save time during the generation of the tendons. However, besides this, there's an additional method to generate additional high points by using model lines, separate model lines. I will come to this later on. However, this option here, or this table, gives us now the control which high point should actually be considered. For instance, I could simply switch off this high point here in the center. However, I'm not allowed to switch off one of the start or the end points. Okay, let's leave this on as it is by default. Confirm with OK or with cancel. The next section over here is construction sequence, and this gets quite important right now because after generating the tendons, you're going to export the structure to the SOFiSTiK Structural Desktop. The SOFiSTiK Structural Desktop will be the platform for you to calculate the results based on the tendons in the structure. For now, we can keep this at the default on 11. We assume that all the tendons, what we are going to generate in a second, are in the same construction stage and will be tensioned or stressed at the same time. Furthermore, there is the section pre-stressing, and this gives us actually the possibility to apply different behavior of the pre-stressing procedure. For instance, from which direction I'm going to stress my tendons, or from what pre-stressing procedure you're going to use. The default is tension plus slip. However, you can also tension, release, pre-stressing, and then let the slip into the system. Furthermore, you can also select some stress limits. The default is again according to the code. However, user-defined is possible also. So you can also enter here the max and the mean pre-stress force for your structure. I will stick here on the according to code option. So let's have now a look to the geometry we have generated based on this information. Let's export, or let's generate the system for the first time. So what are the steps we need to take for this one? First of all, I'm going to the tab SOFiSTiK Analysis. To generate the analytical model or the calculation model for the FEA analysis later on, we have here in the SOFiSTiK Analysis tab this button Analyze. And before I do that, it is important to understand to switch to the 3D view, because I'm going to work on the 3D system. Because when I'm clicking on the SOFiSTiK Analyze button, my elements shown on the screen are going to be considered. So let's have a look what happens when I click on Analysis. There is an additional user interface which gives me possibilities and options how to perform the calculation. So I've activated the analysis load cases just to give you an idea how it looks like straightforward when I calculate the project directly here in Revit. So I click on calculate, and we need to wait a second. So end of calculation, system generation was successful. I closed this over here. Before we have a look in the system visualization, one more important thing, because it is also very important for you as an engineer to double check your entered values of the tendon systems. And to access, for instance, the losses and the stresses of your system, you need to go to the report browser over here. Doing so will open the SOFiSTiK Report Browser 2020, and on the left hand side we have the content, and this is divided between the results and the graphics. In some cases it's meant that graphic is activated in the first place, so simply switch to the first tab and go down to tendon calculation tendons. And when I click on one of this geometry of reference axis, I see already quite a lot of numbers over here. And also when I click, for instance, on the Prestressing System Tendon 1, I also get a summary of the information I have entered in my prestressing system. Also, I have here a warning that my Tendon 1, the edge distance, is less than required, actual 50 mm, but required 260 mm. So let's have a look where we can find this information. However, in that case, it won't have any effect, but again, let's double check this. So basically this information is related to the prestressing system, which is available here. However, there's no option to modify this prestressing system. Therefore, we need to go to the settings in the SOFiSTiK Analysis tab. And within the settings, there's quite a smart application or option available. It's the SOFiSTiK Data Management. And within the data management, you will get all the necessary information of the analysis related inputs of your projects on one place. And for us currently, most important is the prestressing system. So we have only one available. I select this one, and at the bottom over here I got additional functions. For instance, start the editor for a selected prestressing system. I will do that. And within this prestressing systems editor, I see the necessary input for my prestressing system. And as you remember, we are looking for the information of the minimum distance between axis and the slab edge. And this is the last value over here, set by 260 millimeter. Just to control it, require 260. So this value is entered over here. However, basically the arrow or the warning actually pops up because our definition is the distance from top 50 millimeter. But this is absolutely fine for our example, so we understand the reason for the error and we do not need take further action on this one. However, let's have a look now to the graphical output to double check the tendon geometry in the slab. So we here have quite nicely within the report browser an overview, or at least it is a section along my tendon geometry with all the information of the distance in vertical direction. So we have over here the information of 0 because we actually start the tendon exactly in the center of the slab, and the bottom distance was set by 50 millimeters over here, and also the top distance was set at 50 millimeters. So we can simply double check this information. Furthermore, there's also the stressing diagram available for these tendons, what gives us further details of the applied stress of the tendon. Okay, so now as we know where we can find the information, what was generated based on our input for the tendons, let's switch to the next application, and this is now the system visualization. Basically, I'm not jumping into the calculation yet of the tendon forces. I just want to check the system again based on my input. So I open the system visualization and it will open immediately. So we see straight away the FEA structure is available for us for the calculation, and actually we have already calculated something. It was the dead load case as we activated this option during the export window in Revit. So click on this one and we see already a nice deflection. I will stop this over here. In the next step, I want to activate the transparency, and I switch back to system, and we can also visualize the tendon geometry quite nicely in this system visualization. However, there are no results available yet based on our pre-stressing. So this is what I like to show you now. To calculate the pre-stressing in your project, we need to export or generate a SOFiSTiK structural desktop input file. This is a straightforward process. We simply, because we have already calculated the main system, so there is already SOFiSTiK data available, and we actually have visualized it already in the system visualization tool a second ago. So to access this SOFiSTiK structural desktop, we simply need to click on this button over here. Before we can start, the program asks what kind of template it should provide you for recalculation. So I'm going to select this SOFiSTiK Buildings English template. So next step, the program will open the application. And you see already, it looks like similar as the system visualization. However, with the difference, on the left-hand side and on the top, I get a bunch of commands and tasks available to do a further and more accurate design for my structure. Before I jump into these options and the calculation of the tendon forces, let's have a look on this message we have here on the screen, which says there simply that the pre-stressing system was inserted to your project. So we can simply confirm this by hitting OK. As we are only interested in the analysis results, so in results, so we are not performing any design yet, we can simply remove all those tasks in the sidebar in this project navigation straight away. Also, we are not going to perform a superpositioning, so we can delete this as well. First of all, we need to insert a new task called Construction Stage Manager. And therefore, I use the right click over here, or if you prefer to use the commands over here, we can also insert a task by hitting this button. What it will do is it opens the library of all the SOFiSTiK tasks and allows you to add this task to your project. And we are going now to calculate construction stages for our tendons to get our results. Therefore, we need to find within the calculation section over here the construction stages. I simply confirm with OK. In the next step, I'm simply double click on the task. And here we go, we have the Construction Stage Manager in front of us. So what happens here? Basically, it provides you the possibilities to build out an entire construction sequence of your structure, of your project. In our case, we have a simple slab, so we are not going to focus to activate any different floors or members or parts or whatever. So we keep it simple, and what we are going to do is we simply consider, after we have activated the self-weight, to activate the pre-stressing and also add a creep until opening. So basically the program already recognized the pre-stressing, and we see it here at stage number 11. If you remember, when we're heading just quickly back to Revit, we have also the construction sequence information over here in Revit in the sidebar, and it is called stage application, and we have entered the construction stage 11. And when we head back to SSD, we see also the stage number 11 here. So you see, the program automatically recognized this information from Revit. There are some more tabs available. For instance, activating or deactivating groups can be used for activating different floors or levels of your buildings, Also, you can activate loads or deactivate, for instance, for construction loads. And furthermore, control parameters or selection for subject prints and the text output. However, for us now it's more important to stick with the first step for the stages. So basically, to get the results of the pre-stressing over here, we can keep everything on default and simply confirm this by OK. The calculation is quite quick, it just takes 1 second. We are working actually on a really small example. So, however, let's have a look what happened now to our system visualization, what was changed. So, main change is, of course, because we have performed now a construction stage analysis, we get quite a bunch of result load cases. So, let's have a look into the different results and what they actually bring with them. So, for instance, let's double check the load case result 4011. Pre-stressing. So what we get here is the deflection of the pre-stressing plus all previous available stage results. So it is actually an accumulated result of all previous stages. I will switch the amplitude to a constant value of 20, and also I will swap to a XZ view. So when we have now a look to the load case number 5011, we see only the results of the pre-stressing. So there's no self-weight included, there's no creep and shrinkage or anything else. This is only the pure system plus the forces and deflections, of course, of the pre-stressing. Okay, however, this project, or at least what I have entered here, is not a quite realistic example, because as you remember, we had a high point over here, we have another one over here, but we haven't any support, so that's actually not the realistic case. And also we have another high point over here. So let's change this geometry a little bit to make it more likely for a single span system. So what I'm now going to do is jumping back to Revit to change the input. So first of all, I'm going to modify my geometry, and by clicking or selecting the geometry, switching to SOFiSTiK structural properties and jumping into the stations, because now I would like to deactivate this intermediate high point, which was, as you remember, represented from this axis or from this grid line. So I confirm this with OK. So this line is not going to be considered anymore as a high point. What I like also to do is just to add more tendons, just to make a more realistic system over here. So therefore I go to modify, you use simply the command copy and copy from here to, let's say, 500. Then I copy again from here to 500, and I copy again to 500 over here. Then I select those three and I copy those also over here to 3000. That was too much, sorry, I move it back, bring it back over here to 1000. So we have now a distance of 500 in between the tendons. Okay, let's double check this tendon I have copied, just to ensure that this center intermediate support or high point isn't activated, and perfect, all the changes of the copied element were considered. So in the next step, again, we are going to analyze the structure. We confirm everything by clicking on calculate. Now the process starts again. It will generate the tendons, the system, and also performs the calculation of the dead load case. So again, we are open the SOFiSTiK structural desktop to check our system, and we see already here on the face of the slab these nice little circles which represent actually the new tendons. So we have already the dead load available because we have still activated this option during the export. But we need to recalculate the construction stages. So basically I showed you how to calculate this again by opening the construction stage task and hitting the OK button. But there's a much quicker way to perform a calculation of a task in the project navigation. Simply right-click on the task, go on Calculate Construction Stages, and it will perform the calculation straight away. Okay, again, just 1 second, that's fine. And let's now check our results. I'm going again, fix the amplitude to 20, and I go to an XY view to check this result. So the self-weight, I stop, let's freeze this. I need to again enter 20 and go to self-weight, pre-stressing, and here we go. We see already the pre-stressing we've added has now a much bigger effect on our system, and we get an uplifting. Let's compare the pre-stressing of load case number 5011, and of course we have a much higher deflection in the positive Z direction as in load case 4011. Just to remember, the reason is in load case 4011 the self-weight is already considered. In the load case 5011 only results of the pre-stressing are considered. And that's it actually. This is the workflow to generate tendons in Revit and use them further for the calculation in SOFiSTiK Structural Desktop. But there's one more thing I want to show you. It is how to create additional duct station points with single model lines. So therefore I jump back into Revit and I'm going to my level view 2, and here I'm going to generate a new model line. So therefore I go to structure, model line, and I go straight away into the line style. And I think the default on from Revit is lines. So you can straight away change this type to SOFiSTiK Tendon Duct Station. It is also possible to do it later on the property of the model line. However, you can already select it at the very beginning before creating the line. So I select SOFiSTiK Tendon Duct Station and I simply create a line somewhere here. Okay, I close the command with double escape. And basically when I click on this line and I open the properties, we see here the line style. And this is all we actually need, because now when I jump to structural properties and I select one, or let's select all of them, all of my tendons, and I change or I open the edit stations command, and we see already here it's station 2962, a completely random number. I got an additional high point, and I again can select this high point if I want to consider it or not. When being in this automatic mode, this will always be a high point. So you can't define any low points in your geometry. So just keep this in mind. If you want to have a completely user-defined geometry, you will need to go to user-defined. And let's have a look now how this looks like. So you see all the definitions are now not longer available. And when I click now on stations, I get a more advanced input for the tendon layout. And again, we have our positions 0, 2962, 5000, 10,000. So still only this support line is activated, and I can now select the axis of reference. If this is from top, from bottom, from center, if I can also add the information of the axis distance to the edge, inclination, is it free or horizontal. So quite more advanced options over here. So I stick here with the automatic anyway. So just to give an idea how it looks like when I'm going now to export this one, I switch back to the 3D view and jump also back in the SOFiSTiK Analysis ribbon, the most left command, Analysis, click on Calculate and generate a new system. And I can close this one and I jump straight into SSD in the SOFiSTiK Structural Desktop, and I'm switched to transparency view, and I can already see the change of my tendon geometry. So this is definitely a quite useful tool to modify or to create your tendon geometry the way you want. And this brings me already to the end of this video. I hope the information or the workflow I presented is useful for you to jump into this new feature of SOFiSTiK 2020 on the Revit platform 2020 to generate tendons straight away in your Revit project. So no workaround or bypass with other applications or plugins required. You can straight away define them in Revit, bring them to SOFiSTiK Structural Desktop, perform the calculation of the tendon to get out the forces, as well the creep and shrinkage information, and then use this information further for your design. If you haven't subscribed to my channel yet, please do so. It really means a lot to me. And also, if you want to see any different topics, if I haven't presented yet, please get in touch with me. I'm happy to consider this in the future posts here on YouTube or on my website, gudealtersberger.com. Enjoy the rest of your day, and yeah, take care.